Good evening to all. In previous lecture we have started our fifth topic, probability, in which we have seen that introductory part, important definitions, and first binomial distribution and its some examples. Now one of the important example we are going to study, that is a fit a binomial distribution to the given data. Here in this example, in an experiment with 500 seeds in a group of 5, the following results are obtained. X is equal to possible values of x are given 0, 1, 2, 3, 4, 5, and corresponding frequencies are given 10, 70, 150, 160, 80, 30. Total is 500. Where F denotes the number of groups which X seeds germinated. Fit binomial distribution to the data. That kind of questions are very important in the exam. Okay. Here important formula for finding the mean is that x bar is equal to summation fi into xi divided by summation fi. Values of x. First our target is making the table. Given values of x, write this values of x, write the values of f, then calculate f into x, take the summation fi into xi and take the summation of fi. Summation fi is nothing but capital N. Therefore put these values, all these values in the above formula. X bar is equal to summation fi xi divided by summation fi. We get 1320 divided by 500 means 2.64, and here n is equal to 5. Total observations are 5. Okay, that's why small n is equal to 5. Mean means x bar is equal to small n into p. Here mean is now calculated is 2.64 is equal to 5 into p, and we can calculate p is equal to 0.528, and we know that p plus q is equal to 1. From that we can easily calculate q, and q is equal to 1 minus p. 1 minus 0.528 is nothing but 0.472. Okay, by binomial distribution we know that distribution function p of x is equal to ncx p raised to x into q raised to n minus x. This is distribution function of binomial distribution. Okay, p of x is equal to, here n is equal to 5, put these values and values of p and q in this. Okay, and after the calculation we get p of 0. We have to calculate here p of probability at x is equal to 0, because first value of x is 0, then 1, 2, 3, 4 we have to calculate. Okay, first we will find p of 0. For that replace x is equal to 0. We get 5c0 into 0.528 raised to 0 into 0.472 raised to 5 minus 0. We get after calculation 0.0234. 5c0 means 5 factorial upon 5 minus 0 factorial into 0 factorial. Okay, expected frequency is equal to capital N into p. 500 into 0.0234, we get 11.71 means near about 12, and probability of at 1 is equal to 5c1 into 0.528 raised to 1 into, replace the here x is equal to 1 in a standard formula, and calculating we get p of n is equal to 0.1310, and expected frequency is capital N into p. Capital N is nothing but this value 500. Okay, after that we get 500 into 0.23. after calculating we get 65.1151 is nothing but 66. Probability at x is equal to 2 is, replace x is equal to 2, we get 0.2931. Similarly we can calculate capital N into p. We get 146. Okay, just calculate p of 1, p of 2, p of 3, p of 4, and put all these values in a tabular form, obtained value. Okay, this is the question, and this is our answer. This is a working rule for fitting the distribution. Okay, important question are there. Again another question is given. 7 coins are tossed and a number of heads are obtained is noted and experiment is repeated 128 times, and following distribution is obtained. The number of heads here and frequency is there. Fit the binomial distribution. Same question is there. First make the table, find summation fi, find summation fi xi, then find x bar. Here n is equal to 7, small n is equal to 7. We know that x bar is equal to n into p. Calculate then p, values of q. We know that standard probability distribution is ncx, p raised to x into q raised to n minus x. Okay, then put these values of n is equal to 7 in this and find one by one values at x is equal to 0, at x is equal to 1, 2, 3, 4. Okay, and make the table of them. This is the simple questions. Okay, an important question. Now we are going to study, today we are going to study Poisson distribution. A random variable x is said to follows Poisson distribution if the probability of x is given by p of x is equal to e raised to minus m into m raised to x divided by x factorial, and values of x are 0, 1, 2 dash dash, where mean is equal to here small m greater than 0. What are the uses of Poisson distribution? The number of death due to the disease like heart attack, cancer or coronavirus. Okay, these are the examples of Poisson distribution or Poisson variable. Number of accident during a week or month, number of phone calls received at a particular telephone exchange during a period of time, number of defective articles in a lot, number of printing mistakes on a page of book. These are all the examples of Poisson distribution, or these are examples follows Poisson distribution. Properties: we use the distribution when n tends to infinity and p tends to 0, and variance is here m, means mean is also m and variance is same. This is very important property. Variance and mean is same in this Poisson distribution. Okay, first question is that between 2 and 4 p.m. the average number of calls per minute coming into switchboard of a company is 2.5. Find the probability that during a minute there will be no phone calls and exactly 3 phone calls. Okay, first example is given that between 2 and 4 p.m. the average number of phone calls per minute coming into the switchboard of a company is 2.5. Means average means mean is given 2.5, and find the probability that during a minute there will be no phone calls or exactly 3 phone calls. Here this is the example of Poisson distribution. By using a Poisson distribution, we know that standard of PDF means probability distribution function for Poisson distribution is e raised to minus m into m raised to x divided by x factorial. Here m is the nothing but mean. Okay, and here mean is given that 2.5. Replace this value in standard formula, and no phone calls. First our target is find the probability that during a minute there will be no phone calls. First target is that. That's why we have to calculate probability at x is equal to 0, means no phone calls. Replace x is equal to 0 in standard formula and we get for 0.082. Now second question is that exactly 3 phone calls, means we have to calculate probability at x is equal to 3, means p of 3 is equal to e raised to minus 2.5 into 2.5 raised to 3 divided by 3 factorial. After that we get 0.2137. Okay, this is the answer. Okay, simple questions are there. Such a kind of questions are very simple. Just write the probability distribution function, then mean is given in the question, replace this value in formula, and then we know that how to find the target. No phone calls means at x is equal to 0, exactly 3 phone calls means at x is equal to 3. Okay, now if the probability that an individual suffers a bad reaction from a certain injection is 0.001, determine the probability that out of 2000 individuals exactly 3, second is more than 2 will suffer a bad reaction. Okay, here question is given that if the probability that an individual suffers a bad reaction from certain injection is 0.001, determine the probability that out of 2000 individuals exactly 3 or more than 2 will suffers a bad reaction. Okay, this is the example. Now here they have given that probability of reaction is individual reaction is P is equal to 0.001. Here N is equal to 2000 is given, and we know that X bar is equal to N into P. Okay, N into P, mean is nothing but small n into P, 2000 into 0.0001, and after calculation we get X bar is equal to 2. By Poisson distribution, we know that distribution function is P of X is equal to e raised to minus m into m raised to x by divided by x factorial. Replace m is equal to 2. Here 2 is mean, okay, and m is mean, and replace this value in standard formula, and we have to calculate at exactly 3, probability of exactly 3. Therefore put x is equal to 3 in this formula and calculate. We get 0.1804. okay. Now second is more than 2 will suffers a bad reaction. More than 2 means probability, we have to calculate probability at x is greater than 2, means 1 minus probability of 0 plus probability of 1 plus probability of 2. Greater than, we have to calculate probability at greater than 2. That's why we are subtracting from 1, and we get P of 0 is equal to e raised to minus 2 into 2 raised to 0 divided by 0 factorial. After calculation we get 0.1353. Then if we replace x is equal to 1 in this formula, then at x is equal to 1 we get the probability. Now probability more than 2 is 1 minus probability of 0 plus 1 plus probability 0. After calculation we get this 0.321. okay, we have to calculate probability more than 2. How to find is here. Okay, keep in mind such a kind of questions are important, such a kind of conditions are important. We have to calculate here probability more than 2 means total probability is 1, and if we subtract probability up to 2 from 1, then we get our desired destination. That's why this formula is here 1 minus probability of 0 plus probability at 1 plus probability 2 is taken. Okay, important question or important condition is it. Okay, now similarly next question is using the Poisson distribution find the probability that ace of a spread will be drawn from back of well-shaped car at least once in 104 consecutive draws. Okay, such a kind of questions are very easy. Just we have to read question more and more times, then we get the idea about it. Okay, now in certain factory producing a cycle tires, in a small chance 1 in a 500 for any tire to be defective. The tires are supplied in a lot of 20. Using a Poisson distribution, calculate the appropriate number of pots containing no defective, 1 defective and 2 defective tires respectively in consignment of 20,000 tires. Okay, here we have probability of 1 defective in out of 500. That's why P is equal to probability of success is here 1 upon 500 is nothing but 0.002, and mean is nothing but N into P, means 20 into 0.002 is nothing but 0.04. For Poisson distribution, we know that standard formula is e raised to minus m into m raised to x divided by x factorial. Here m is nothing but mean, and which is 0.04. Replace it in a standard formula, and first condition is we have to calculate containing no defective, 1 defective and 2 defective. No defective means probability at x is equal to 0. Just replace x is equal to 0 in that formula, we get 0.9608 answer. Now similarly, expected number of lots having no defective is nothing but capital N into P. Capital N is here, we have to calculate capital N is, we have provided the tires are supplied in lots of 20 and total are 2000. Therefore 20,000 divided by 20 is our capital N is nothing but 1000 into P is 0.9608, and after calculation we get 960.8, means 961. Now first probability of 1 defective is, if replace x is equal to 1, we get 0.04. Expected number is 1000 into 0.04 is nothing but 40. Probability at 2 defective, if we replace x is equal to 2, we get e raised to minus 0.04 into 0.04 square divided by 2 factorial, we get 7.68 into 10 raised to minus 4. Expected number is nothing but capital N into P is 0.768. Okay, such a kind of questions are asked here. Next question is manufacturers of a pin knows that an average 5% of his product is defective. He sells pin in the boxes of 100 and guarantee that no more than 4 pins will be defective in how many boxes out of 1000 he will meet. Okay, such a kind of question is the guaranteed quality guarantee. Okay, now here they have given that 5% are defective, that's why probability of success is 5 upon 100 is nothing but 0.05, and here n is equal to 100, mean is nothing but n into p, 100 into 0.05 is nothing but 5, and p of x is equal to e raised to minus 5 into 5 raised to x divided by x factorial. Probability of no more than 4 will be defective, means probability of x greater than or equal to 0, less than or equal to 4, we have to calculate this. Not more than 4 defective means up to 4 defectives, means no defective, 1 defective, there may be 2 defective, there may be 3 defective, there may be 4 defective. That's why we are adding probability at 0, 1, 2, 3, 4. Okay, just calculate one by one it. P of first we will calculate P of 0, then P of 1, P of 2, P of 3, P of 4. Just replace values of x. Okay, and after that adding we get total probability more than 4 will be defective is this. Now no number of boxes having not more than 1 pin will be defective is n into p. 1000 into 0.4405 is equal to 4405. Okay, means 440 is the answer. Now here again fit Poisson distribution to the following data. Such a kind of questions is also important. Fit Poisson distribution to the following data. Here values of x are 0, 1, 2, 3, 4. If corresponding frequencies are given 109, 65, 22, 3, 1, and total is 200. Okay, here we have mean is nothing but summation fi into xi divided by summation fi. First we have to make the table, values of x, values of f, and values of fi into xi, then calculate summation fi, then calculate summation fi into xi, and we know that formula x bar is equal to summation fi xi divided by summation fi. After calculation we get x bar is equal to 0.61. X bar means mean. Okay, and now by Poisson distribution we know that formula is p of x is equal to e raised to minus m into m raised to x divided by x factorial. Here m is mean and x bar is also mean, therefore put the values of x bar in place of m and then find one by one the values. P of 0 is 0.543, expected frequency is n into p is 109. Then calculate P of 1.33, expected frequency is we get after calculation 200 into 0.33 is nothing but 66. Then calculate P of 2, replace x is equal to 2, and then we get 0.101, and expected frequency is nothing but 200 into 0.101, we get 20. Okay, similarly we can calculate P of 3 is 4, P of 4 is 1, and make the table of all the values, we get our desired answer. Okay, fit Poisson distribution. Next question is fit Poisson distribution of the following data. Same question is there, just we have to calculate summation fi xi, then x bar, put the values of x bar in place of m, and then finding one by one values of distribution. We get P of 0, then P of 1, P of 2, P of 3, P of 4, and make the table of it, and we get our desired answer. Okay, next question is same, fit the Poisson distribution. It is very important or easy topic, don't miss this topic. Okay, only 3 distributions are there, we have to only understand 3 formulas. Okay, it is very easy topic. We will meet in the next lecture. Normal distribution we will see in the next lecture, normal distribution. Okay, take care from coronavirus, stay at home, be safe. Now we are going to stop.